Hello everyone, my name is Ritam Balik and you're watching Balik Robotics. So this is our second video of SVM. In this we are going to study what are nonlinear SVM and what are kernel function. So without wasting much time, let's jump onto the video. Okay, so let's quick recap. What are SVM? SVM is support vector machines. These data points are support vectors, and this is our algorithm is our machine, which what it does is like make a hyperplane and two boundaries, and it's try to maximize the margin. So this was all about SVM, which we studied in the previous lecture. And now, before starting, let's see what is linear, nonlinear, inseparable data set. So linear data set is the data set which we can make using only one simple line. Okay, we can separate this data like plus and squares using only one single line. Nonlinear data whereas is the data which we can't separate using one single line. You know, like we are plotting, it's not a circle also, it's something else. And inseparable is like we can't separate it using line, we can't separate using like, you know, circles or other shapes. So this is inseparable data. Now, for the normal data set, which is linear, what we does is like we give an input, we use SVM, and we have a good output. Now, but we have a like nonlinear data set. So what we do, like we use input, we add a kernel. Kernel is like different function. Kernel are one function which just help us to make our data multidimensional. How we can apply, how can we make a function is like different kernel is like different data set require different kernel which we have to make it. We will see in the coding. The kernel give the high dimensional input, and then this high dimensional input is fed in SVM, and we got an output. So this is what the kernel does to our data set. Like this, we have a data. You can see that this is a non-linear data. Our kernel make a extra dimensional, like it make 3D. And now SVM gave us a hyperplane in the 3D, which separate our squares to the green. If we see in here, it's like this is our input space, and our kernel make it in a cube, and we our SVM cut it using a hyperplane. So this is all about kernel, and this is about linearity and non-linearity. So when we have a non-linear data and we want to use SVM, we just need a function or a kernel which make our data 2D data to 3D. If the data is 1D to, then it's make it 2D, and then we can easily separate a data set. So this was literally all about the kernel. Now you know what is SVM, you will know that what are the kernels and what are the, what I say, non-linear things. Okay, now, okay, so let's jump to the start where we started the SVM. In SVM, first of all, we question what support refer to the support vector. The support or define the position oriented of the decision boundary. So this is the support vector, define where the decision boundary is. Now we can easily like understand what is written here. And secondly, where we lost here, effective in high dimensional spaces. So we literally just showed that it is not like so good if the image is 2D, but the image is 3D, then we can easily use this. Okay, like choosing, yeah. So how to choose the right kernel and what kernel it is highly tricky. Like how we can use use a function which can make our data from this to this. This is a very tricky part. So that's why this is a con. So this was all about SPM. Let's meet in the second video and code how we can use SVM for linear and both non-linear dataset. So Until then, bye bye. We'll meet you in the next video. And if you are new to the channel, then please subscribe.